Hello everyone. Today I want to show you how to implement a QPSK or HPSK demodulation in a GNU Radio simply. This design works perfectly for practical signals, and I will show you its performance on the modulation of a practical signal. For more details on the theory of digital receiver for classical modulation, you can see my previous video which I uploaded 1 year ago. You can find the whole details with a related article on this topic. Today I use GNU Radio blocks for implementation of the QPSK demodulator. As you can see in this design, in the first step I load the recorded signal using a file source block. And this is a stereo recorded signal with short format. That means the signal is recorded as a 16-bit signed integer INQ. I use the iShort to complex block to convert the signal to the complex format, and using the DDC digital down converter transfer signal to the baseband. Then I use a low-pass filter for filtering other harmonies and other unwanted signals. As obvious here, I use low-pass filter block which has some useful option. For example, it has a decimation factor that is used for reducing the sampling frequency rate and that improve the speed of the modulation. After a low-pass filter, I use a rational resampler somehow to have a 4 sample per symbol. I call it SPS. To configure this block, you need to set two parameters. One is the interpolation and another is the decimation factor, which I use the UF variable for interpolation and the DF variable as a decimation factor. I compute the UF and DF factors based on symbol rate somehow to have a 4 sample per symbol. After a rational resampler and before the modulation, you need to normalize the signal. So here I used a RMS calculator block for normalization. Now the signal is ready for the modulation process. Up to this point that I have explained is preprocessing steps for prepare the signal for the demodulator. In the previous version of GNU Radio, you can simply utilize MPSK receiver block here as a demodulator, and you just need to configure the MPSK receiver block parameters according with your desired signal. In this block, there are some parameters for configuring the demodulator. Here M stands for modulation order, and for QPSK you should put M equal 4, and for HPSK you should put it equal 8. The other important parameters are loop bandwidth, mu, and its gain. The details of this parameter mentioned in this block documentation section, and you can read this document and configure this parameter simply. One of the other parameters in that block is the omega. Omega, it is in fact the number of output samples per symbol. And if you want to have a 1 sample per symbol in the output, you should put omega equal a SPS value. The loop bandwidth parameter is used for adjusting the phase and frequency tracker algorithm, and mu and its gain is used for adjusting the timing recovery algorithm or symbol synchronization. As I explained in the documentation of MPSK receiver, this block in fact uses a constant loop algorithm for phase and frequency tracking and uses a symbol synchronization for performing a timing recovery. After that, you have a constellation, and if the receiver works perfectly, you should have a constellation point according to the modulation order in the output. I use the Qt GUI constellation sync to watch the constellation of output during the demodulation process. In the last version of GNU Radio, I used a custom loop block with a single sync block to perform a digital receiver. I used custom loop for tracking phase and frequency as well as a single sync block for performing timing recovery. In the symbol synchronization block, you can select different timing recovery method. Here I prefer to use Gardner method. After the symbol sync block, we anticipate having a QPSK constellation and use it to evaluate the receiver performance. After that, I use a constellation decoder and translate the constellation to the bit and save the bit stream in a file using a file sync. Here, as you can see, I use the constellation object to define a standard gray mapping to translate the constellation to the bit. Now, I run the algorithm and project and you can see it works perfectly. If you want to change the QPSK demodulator to MPSK demodulator, you just need to change the order of modulation in the custom loop block and symbol sync block. I must add that you need to adjust the following 4 parameters according to your desired signal. These parameters include sampling rate of input signal, carrier frequency of desired signal, symbol rate, and the bandwidth of signal. You should set these parameters precisely based on your desired signal. After that, the demodulator will work perfectly. I adjust these parameters based on my target QPSK signal, and now I run the project. As you can see, the constellation shows the status of demodulation, and also in another design, I adjust this parameter for MPSK signal. After run the project, as you can see, the output constellation shows the demodulation live perfectly. I hope this helps you. In the next video, I will use this design for demodulation of offset QPSK signal, and in that video, I will explain how to change this design to construct a perfect demodulator for offset QPSK signal. Thank you for watching.